Okay, so we'll start a new discussion, multi-dimensional. I mean, two-dimensional repeated summation. Okay, many things we have seen in calculus. Repeated addition is integral calculus. Multiplication is integral calculus. Division is differential calculus. That's it. Okay, what about repeated addition in two dimensions? What are you talking about? Repeated addition in two dimensions. Two dimensional repeated addition. Okay, what is your one dimensional repeated addition? One dimensional repeated addition, what we mean? One dimensional repeated addition, what we mean is if I have x axis, and then this is 0 to alpha on x-axis. I am taking point 0 to alpha on x-axis, and then I divide this between 0 to alpha into n different sections. N different sections where n tends to infinity, where n tends to infinity. If that is the case, then in each section of this n, there are n sections now. Between 0 and alpha, there are n different sections. In each section, I have a bar, vertical line. In each section, I have a vertical line. If this is x-axis and this is y-axis, this is x-axis, this is y-axis. Now I can say the vertical line in each section. How many vertical line you have? I have I have n number of vertical lines where each vertical line spans over one section, one section, one section, one section. Total number of vertical lines are n, and 0 and n vertical line is in a span of 0 to alpha. Okay, makes sense? Now, if I add all the vertical lines, if I add all the vertical lines, then this is called two dimension. Two dimension, single dimension, single dimension. In a way, I have function over x, I have summation sign, sigma sign, summation I equal to 1 to n, summation I equal to 1 to n, and then function over x. That's it. Okay. Sigma summation sign I equal to 1 to n. N times I have to sum. What I have to sum? The vertical bar. Function over x, where x equal to I by n. That is the distance from here. If I talk about the ith section, I equal to 1 to n, means I is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to n, where n in reality it is 0 to x. Okay, 0 to alpha on x-axis. Now, if I talk about any ith section, then function over x at x equal to I by n. Means if I talk about ith section, then from origin, the x is I into width of one section, that is 1 by n. I into 1 by n, I by n. Okay, in this fashion, we have now summation I equal to 1 to n function over x, and then at x equal to I by n. This is one summation, and this is considered as single dimension. If I call it single dimension, because independent variable is only one. What about two dimension? Two dimension means independent variable is x-axis and independent variable is y-axis. Two independent variable are there. Or rather, we can also so three dimension, because we are talking about volume now. Now consider three dimension. What is your three dimension? Consider this is x-axis, this is x-axis, and this is y-axis. In that fashion, now if I take any point here on this plane, then that is x comma y. Consider there is a point called alpha comma beta. Makes sense? Alpha comma beta. And in that fashion, I divide this is x-axis and this is y-axis. I take any point on the x-axis, this is x-axis. I take any point on x-axis as alpha, and I take any point on y-axis as beta. Okay, I divide 0 to alpha into n different sections. Similarly, I divide 0 to beta into n different sections. Now, if I take here, then from this alpha, I have a point here called alpha. And from beta, this is origin. From beta, I have a point here called beta. Now, this is a point. This is origin. And this is a point I am talking, that is alpha comma beta. Alpha comma beta is a now mesh of two dimension, n into n. Mesh of two dimension, n into n. How I can describe now the I said summation I equal to 1 to n fx at x equal to I by n. Make sense? Now consider that I have ith section in the here and ith section here in the y ith section. Ith section, ith section. Somewhere I am here. Okay, what about this now? If I talk about summation, summation I equal to 1 to n, I equal to 1 to n, function over x comma y, because both are independent now. Function over x comma y, where x equal to I by n, y equal to I by n. Okay, if someone is very smart enough, he can think about two summation. Summation I equal to 1 to n, summation j equal to 1 to n, and fxi comma yj, whatever it is. Now we are landing up into three dimensions, where independent components are in two dimensions. Earlier when we talked that independent component x-axis is only in one direction. Okay, and then we had y-axis that were dependent upon x-axis, known as fx, function over x. Okay, summation of I equal to 1 to n, function over x, where x belongs to ith section. Okay, what is the good about it? If it talks about probability, where each bar is a probability. If I add all the bar in this section, it must sum it to 1. It must sum it to 1. Means summation of I equal to 1 to n fxi equal to 1. That is guaranteed. Because we are drawing a probability chart. What is your probability chart? I have given already example. Consider a class has 10 students, and this is the marks line. This is the marks students are getting, and y-axis is number of students in the class. At 50 marks, there are 4 students. In probability chart, I will say it is not 4, it is 4 by 10. At 50, the height is 4 by 10. At 60, there are 3 students. Height is 3 by 10. At 70, there is 1 student. Height is 1 by 10. And at 40, height is 2, 4 by 10. Okay, if I sum all the probability heights, these are probability height. If I sum all the probability height, then it becomes 1. It must become 1. Okay, in that fashion, this is called probability chart. Now, similar fashion, if I say I have x-axis and y-axis, I have divided into n different sections from 0 to alpha, n different sections, and every section has a probability bar. If I add I equal to 1 to n fx, it must resolve into 1. Okay, that is called probability chart. I can redefine the summation into integration that we have talked. If I want to redefine summation into integration, I can rewrite it as summation I equal to 1 to n fx, where x belongs to ith section, equal to summation of I equal to 1 to alpha, same thing, 1 to alpha fx I. But these, okay, equal to, if I have summation I equal to 1 to alpha, where gap is 1 to alpha, and then fx is the height, fxi, that is equal to integration x equal to 0 to alpha fx dx. What is caveat here? Caveat is second is all right. Summation of I equal to 1 to alpha fx, where x belongs to ith section, that is equal to integration x equal to 0 to alpha fx dx. First one has problem. Summation of I equal to 1 to n fx equal to summation of I equal to 1 to alpha. This is only possible when n equal to alpha. Means summation of I equal to 1 to n fx is integration of x equal to 0 to n alpha. Summation of I equal to 1 to n fx equal to integration x equal to 0 to alpha fx dx. Both are same only when n equal to alpha. If n is higher than alpha or whatever, it is different, then both are not same. If I want to sum something as integral calculus, then I have to bring another function. Please watch our previous video, and it was watched very thoroughly. This is what I am saying. Watched very thoroughly, highly kind of. It is advisable that everyone must watch the previous video. I believe pseudo calculus problem. Okay, previous day video. So there we talked about how I can write summation alpha I equal to 1 to n, where n tends to infinity, fx, where x belongs to ith section, as integration x equal to 0 to alpha, and then now it won't be fx. New function will come called gx dx. Why it is not possible? Because if I divide 0 to alpha into n different sections, and n tends to infinity, I have infinity number of bars. And all bar, if it has probability, then it will sum it to, if all bar is, I'm not saying probability, all bar has a height, not a probability height. All bar has a height, then it will sum it to very high value. Okay, what are you talking about? Consider I have a function called, function, I'm sorry, fx equal to x, fx equal to x. Now I am summing from 0 to 10. How much it is? Let's give, I'm taking one example. fx, fx equal to, fx equal to x, fx equal to x. Okay, in that fashion, if I take 0 to 10, how much it will be? Someone can add it. 10 plus 9, 19. 19 plus 8, 27. 27 plus 7 will be 34. 34 plus 6, 40. 40 plus 5, 45. Plus 4, 48. Plus 3, 51. Plus 3, how much it is? 56. It will sum up to 56. This is what I think so. Okay, 56. It looks like n plus 1 into n by 2. This, to me, it looks like this. N plus 1, that is 10 plus 1, 11 into 5. 10 plus 11 into 10 by 2, 55. Okay, let's try it. Let's sum up to 16. Now, if it is 55, more or less I calculated, plus 11, that is 66, plus 12, then it is 78, plus 30, then it will be 91, plus 14, 105, plus 15, 120. Actually, I don't remember. There was some formula here. 120. 1 to 15 is 120. This is what I think so. Now, if I say n plus 1 into n by 2, then 16 into 15 by 2, that is 8 into 120. 15 into 8, I believe it is 15 into 8 is 121. This is what I think so. Okay, not 120, 15 into 8, 8 5 is, and then 121. N plus 1 into n by 2. Okay, consider that I am summing up to 1 to 20. 1 to 20. I have 20 bar. 1 to 20. How much it will be? 20 into 21 by 2. 10. 210. It will be 210, I believe. 20 plus 9. 20 plus 19. That is, I am reaffirming it. 20 plus 19, 39. And 20 plus 19 plus 20 plus 19 plus 18. will be 60 minus 3, 57. Okay, 57. Again 17. Okay, 57 plus 57 plus 17, that will be 71. Right? 74. 57 plus 17 will be 74. 74 plus 16, it will be 8. 74 plus 16, it will be 90. 120 plus 90 is 210. Through our formula n plus 1 into n by 2, it is 210 only. Means it is alright. If I want to sum something, it will be n plus 1 into n by 2. If that is the case, now consider integration of x dx, x square by 2 from 0 to 20. That is 0 to 20. More or less x square by 2 is same as x into x by 2, x plus 1 by x into x by 2. It is similar. That will come as 400 by 2, 200. It will come as 200. If I say I have 1 to 500, I'm sorry, 1 to 50, I have to add. Then 50 into 51 by 2. Same thing. Here also x square by 2, 50 into 50 by 2. More or less, now they are near to each other. Means repeated summation is same. These are not available in any of the book. This basic thing is not available in any of the book. How repeated summation can be brought into integration. If I have x-axis and 0 to alpha, right now it is 0 to 50. Okay, and how this summation now, this is 0 to alpha, 0 to alpha. If I divide into n number of sections, if I divide into n number of sections, where n tends to infinity, and if I write summation of I equal to 1 to n fx, where x belongs to ith section, if I do repeated summation, it cannot become integration of x equal to 0 to alpha fx dx, because the number of summation we are making, it is n that tends to infinity. It is very high. How much it should be? If I am saying 0 to alpha, number of summation must be alpha only. That's why then when only integration works. Like if I say what is your function? Function is x, fx function over x, f bracket x bracket close function over x equal to x. Okay, if it is x, then x dx is x square by 2, 0 to alpha, alpha square by 2. That is only possible, that is alpha square by 2. That is only possible if I 0 to alpha, if I cut at 1 distance and raise the height at fx, then it is same. Otherwise, if I cut in n number of sections where n tends to infinity, and every section I have a bar as fx, then it is not possible. Both are different. How to represent this into integral calculus? That is a question mark. Integral calculus talks about area. Area means that if I have fx as a continuous bar, consider fx, we are talking about fx, function over x. Function over x, if I think it is a continuous line, then fx dx talks about the underneath area. Okay, if I have divided into n different sections and each section is of length 1 by n, I have n number of vertical line where at each point, what is the x at that point? In that fashion, I have the vertical bar. Then if I want summation I equal to 1 to n fx as integration, then integration talks about fx dx is area underneath it. But here there are so many bars that the sum will be very high. In that fashion, I have to multiply every bar with the gap between two intervals. If I multiply with 1 by n, that is the gap. If all the divisions are of same width, that is 1 by n, then it will be area strip. Area strip. If I add all the area strip, then it will become fx dx only. Then it's possible. Means what I want right now is summation of I equal to 1 to n fx delta xi. But someone is saying, no, there is no delta xi, only fx is there. Then you have to bring in delta xi. Height into width will give the area of that section. If you add all the section, it will give the full area. That is fx dx. then you have to readjust the fx now. No, 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 I don't want to readjust fx. I want an integration, not possible. You have to readjust fx, means summation of I equal to 1 to n fx equal to summation of I equal to 1 to n gx at x equal to ith section delta xi, width of the ith section. This will resolve into integration because now I am multiplying height with delta x, it is giving me the ith area. If I calculate gx dx, it will add to the full area. Means summation I equal to 1 to n fx in the ith section equal to summation of I equal to 1 to n gx in the ith area into delta xi. If someone finds a new gx, then it can be converted into integration x equal to 0 to alpha gx dx. These are not available in any of the book. Anyone can try. It is not there at all. In that fashion, fx equal to gx dx, gx equal to dfx by dx. $1 trillion summation. Without understanding summation, you cannot proceed in probability and statistics. And probability and statistics is the root, is the base of artificial intelligence. From there, you have to enter into integration. That is required. From the probability and statistics, there you have to enter into integration. Through multiplication of y fx, you cannot enter into integration in the artificial intelligence arena, where you have numerous data. But data is numerous, and then you are trying to model the data into calculus. There, summation is understanding the summation is required. In that fashion, we have new function gx as dfx by dx. Or if I have gx, that is continuous function. Gx is a continuous function. If I calculate gx dx, integration from 0 to alpha x equal to, it is exactly same as summation I equal to 1 to n fx, where fx is discrete line. No, no, no. I have gx, understood. I have gx. I want discrete line. No. From continuous line, you want discrete line. People get continuous line from discrete line because continuous line only will give the integration, not the discrete line bar will give the integration. No, I want discrete line. Okay, you have continuous. Yeah, I have continuous line. Gx is the continuous line. I want discrete line. If someone has continuous line, if someone has discrete bar, then to get the continuous line, and that equation is gx and discrete bar is fx at any x point, this is the height, then gx is equal to dfx by dx. This is not, I'm repeating again, it is not available in the book. Okay, if I have continuous line at gx and I want fx back, what I can do? Okay, how many sections you want to divide? N section I want to divide. Anyway, gx equal to dfx by dx. If I want fx back, then integration of gx dx will give me fx back. Thank you very much. I have divided into n section. What you want? I want the ith section gx. Okay, from here I have divided your 0 to alpha was there, right? 0 to alpha I divided into n section. Ith section bar height I want to do. Can you tell me? Okay, fx equal to gx dx integration. Integration will be this x ith section. No, this is ith section. Up. This is ith section. What I'm trying to say is this gap is ith section. Last gap is nth section, and this point is alpha from the origin on x-axis. This is ith section. This point is I by n, I into 1 by n. One width is 1 by n. If I divide it into n different sections, n equal section. This is I by n from x-axis, and this is I plus 1 from x-axis. What is this height if I talk in the digital manner? Integration of x from I by n to I plus 1 by n fx dx. What is fx? Oh, I'm sorry, gx dx. Fx at fx at x equal to ith section. What is the height? Fx at x equal to ith section equal to integration of x from I by n into I plus 1 bracket close by n gx dx, where gx is the continuous function. Will it give the height at any certain? No, 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 no. I divided into n part. I told you, right? I divided into n part. That is true. But I am merging three sections here. I am merging three sections here. From ith section to I plus 3th section, I am merging it. In one section, out of three, I want a big bar chart. I want a big bar chart. Integration of gx dx from I by n to I plus 3 by n. No, 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 no. I want from 0 to n. Now, if you talk about the normal integration 0 to alpha, you have alpha number of bar. Then you convert into integration directly. Doesn't matter. No, no, no. From 0 to alpha, I made n section. Yeah, you made n section. But at the end of n section, I want one bar only. One bar only. Then integration 0. Okay, I by n where I is 0 to I by n where ith section is n to 1, 0 to 1, that is gx dx, x equal to 0 to 1 gx dx. Now it will give you what the single bar you want. Okay, this works in probability function also. This is typically probability. If gx is a probability density function, consider gx, there can be two way of talking about probability. One probability is discrete bars. One probability is continuous line. Both are can be described in probability, and both are not same. Obviously, both are not same. The way we said, if I have consider this is unit length. This is what I always say. Consider this is unit length, and I divide into n section. Now, if I hit at any place, any ith section, what is the probability that I will hit at a particular section? 1 by n. If there are n sections, hitting at particular section is, or okay, not hitting. Consider I close my eyes and there are n number of sections. Now I am placing my finger, and what is the probability that it will hit third section? Okay, what is the probability my finger will hit ith section? Hitting any section probability is same. If there are n sections, then hitting any section probability is 1 by n. Means I have bar at each section and each height is 1 by n if I talk about probability. If I want to convert this 1 by n, n time into a continuous bar, into continuous line, how much it will be? Fx is 1 by n. That I want gx into delta x. Gx equal to fx. Fx equal to gx delta. I want gx. What is delta xi? Delta xi is the width of one section, that is 1 by n. Fx is 1 by n equal to gx 1 by n. Then gx equal to 1. Now if I draw in a continuous manner the same height, if I draw in a continuous manner, it will be 1, straight line 1. But if I draw in a bar, it will be height will be 1 by n. That is difference between digital and analogous. Make sense? Okay. No, 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 no. You remember I said 1 unit distance. Consider this is 10 unit distance or alpha. It is 10 unit distance. Now you tell. If it is 10 unit distance and you divide into n number of sections, then each section has a width of 10 by n. Each section is of width of 10 by n. I know it is 10 by n. Anyway, what is the chance? What is the chance that I'll hit in a particular section? Then chance will be, I believe it will be 1 by n only or 10 by n. Someone has to think about it. If one width is 10 by 10, 10 by n, but there are n number of sections. There are n number of sections. Now, if I close my eye and touch the finger, then what is the chance that it will be in I? If there are n sections, then chance of getting in ith section is 1 by n. Now, fx is 1 by n. I want in gx. Then gx into delta x, but delta x is every width is 10 by n. Okay, 1 by n equal to gx 10 by n. then gx equal to how much it will be? N gone 1 by 10. Gx it will be, if I represent this into a continuous line, then line will be 1 by 10. 1 by 10. Okay, makes sense? This is how it is changing a discrete to continuous. Anyway, 1 by 10, if I want area underneath it, if it is 1 by 10 and area underneath I want gx dx, x equal to from where to where? Okay, now x is 0 to 10. If I'm saying, then what is area here? It is 1 by 10, 1 by 10x, 0 to 10. It will be 1. Means this is actually probability density chart. We started with the probability, if someone remembers, that what is the height of each bar? 1 by 1. 1 by n. 1 by n means that is the probability bar. If I say that what is the continuous line equation, that is 1 by 10, I remember. 1 by 10, if continuous line is there gx, and if I integrate over 0 to 10, the net probability should sum up to 1. Or if I add all the bar, the net probabilities must sum up to 1. Like if I have a if I have a 2 coin, and if I throw the coin, what is probability that I will get no head? There is no head at all. That probability is 1 by 4. What is probability that I get one head? Then that is 1 by 2. What is probability that I get both of the head? Then it is 1 by 4 again. Then at the 0, x equal to 0, height is 1 by 4. At 1, height is 1 by 2. And at 2, height is 1 by 4. Again, if we add all three, it should become 1. That is the probability. If I have probability of hitting any section is 1 by n, if I add all 1 by n in n section, it must be 1. If I talk about the probability density continuous function, then if I draw the area underneath it, it must be 1 again. If I want discrete from the continuous, okay, thank you very much. Can you tell me discrete again? Because I know discrete is 1 by n, where there it is 1 by 10. 1 by n, 1 by 10. How I can get 1 by n? I know it, you cannot solve it. Anyway, let's try. Okay, now let's try. I have continuous equation as 1 by 10, and I want discrete height in section ith section. Ith section means this is I and this is I plus 1. This is ith section, consider. Now I am asking what is the height of the bar, because I know it is 1 by n, and he is talking about continuous line 1 by 10. How it is possible? Not possible. Integration from the lower limit to higher limit. Gx dx. I want fx. Gx dx. Dx is 1 by 10. 1 by 10 into dx. And integration lower limit to higher limit. What is your lower limit? What is the distance from here to ith section? One gap is 10 by n, because we had taken 10. 10 I divided into n section. 1 is 10 by n. So ith means I into 10 by n. I into 10 by n. To I plus 1 into 10 by n. 1 by 10 x, and x is I plus 1 by n minus I by I plus 1 into 10 by n minus I into 10 by n. 10 I can take out, and outside 1 by 10 is there waiting there, gone. Now I by n plus 1 by n minus I by n, 1 by n. 1 by n is your height, certainly. This is how we transform discrete to continuous, continuous to discrete. Which one is better? Which one you think it is better? Because repeated summation has limitation, but integration, the way work has happened in integration, then getting integration of anything is possible. But anyway, there can be people who are very good in summation, then for them summation would work. There are people who are very good in integration, for them integration is there. Which is the best solution? Both solution is the best solution. Anyway, now we will come back to our kind of discrete, our two dimensions. In two dimensions, a similar way, x axis I divide into n part. and y-axis I divide into n part. Someone can say I divide into m part, n into m, whatever it is. Now, if this goes till alpha and this goes till beta, then there is a point called alpha comma beta. This is origin. This point is alpha comma beta. In that way, I have this section I have taken out between alpha and beta. If I divided n into n, this is an array of n into n section where x width and y width, delta x and delta y are not same. That is for sure. Now, in that fashion, if I want to draw a bar, where is your bar? This is the bar. Bar, this is three-dimensional now. If I draw bar at every point, that is a function over fxy, not only fx. Earlier we said function over x. Now it is function over x and y. If I draw bar at every point, that is function over x and y at that point. Okay, function over x and y. What is function over x and y at that point? What is function over x at that point? X is ith section into 1 by n, or ith section into alpha by n. If I divided 0 to alpha into n section, ith section if I talk, then I into alpha by n, and here ith section here also if I talk, then I into beta by n. In that fashion, fxy if I talk, then x is I into alpha by n. In the ith section, what is the height? Height is in ith section, x is I into alpha by n, where y is I into beta by n. If I divide both n section, that is the height. If you take all the height and if you combine it, then it will become continuous, but both are not same. The way we say, you cannot just combine all the verticals and you say it is continuous. Continuous is only possible when you have divided 0 to alpha into alpha section and 0 to beta into beta section with gap 1. Then only you can connect all the points and say it is this one. What that point will be? That point will be 3D. That point will be 3D. Okay, we will see 3D. 3D means we will talk probability in 3 dimension also. Probability in why? This is not a matter of fear. In artificial intelligence, probability will come in n dimension. This is 2 dimension and 3 dimension, where we are talking about what will be the probability. The time will come when someone has to calculate probability in n dimension, 100 dimension, 1000 dimension. Now we calculate the probability. Change the discrete lines into continuous line, and then you integrate over 100 variables. Okay, then only you can estimate the weather. Okay, I want to estimate the weather. What will be the cloudy weather today? The day will be cloudy or not? In that session, manner, you have to think about 100 parameters. If there are 100, right now I'm taking about two parameters, x-axis and y-axis. Both are independent to each other. You have to take 100 different parameters and they are orthogonal to each other. What is orthogonal? Changing one parameter will not change other parameters. That is called orthogonal. I have given example of the orthogonal in the past videos also. If there is a person is walking in along x-axis and there is a wind that is flowing in along 45 degree from the person who is walking along x-axis, then he will get assistance from the wind. That is guaranteed. If person is walking along x-axis and wind is flowing along x-axis, then person will get full assistance from the wind. If wind is flowing at 45 degree, then person will get cos 45 degree. 1 by square root of 2. That much effect it will get, help it will get from the wind. If wind is flowing along the minus x-axis and person is walking in along x-axis, then wind will fully opposite. Okay, if person is walking along x-axis and wind is flowing through y-axis, there is no change. Person will not get any assistance from the wind. Person will not get any resistance from the wind. This is called orthogonal component. If I have 100 features, when I am parameters, I am trying to calculate the weather, estimate the weather today. So any whether I divide into 100 different parameters, features, change of any feature should not trigger any change on any feature. This is called orthogonal features. If I have feature like x and y, and if I changing x or y, like wind speed, person is walking along x-axis and wind is flowing along y-axis. If I change the wind speed, then x-axis along person, there won't be any change. This is how we have to find it. That's why dimension reductibility and so many things come in artificial intelligence. We orthogonalize our component so that there should be not any linearity, non-linear, any collinearity. It should be non-collinear. It should not change with each other anyway. That we will see. First, we will take simple example back into circle, finding the surface area of the circle through the multi-dimensional repeated summation. Then we will proceed. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.